Okay, let's talk about graphing sine and cosine. So before we start, let's remind ourselves of our quadrants, right? So we have quadrant 1, 2, 3, and 4. I should do this with different numbers, but that's okay. So we know that all of our trig functions are positive. We know that sine is going to be positive. We know that tangent is positive in quadrant 3. And we know that cosine is positive in tangent 4. So we're going to keep that in mind as we kind of move through our graphs, right? And then thinking also about kind of our points that we have on our unit circle. So we have the point 1, 0. We have the point 0, 1. We have the point negative 1, 0. And then, of course, 0, negative 1. And then for everything else, we're going to go ahead and move through, right, our first quadrant, keeping everything in mind here, right? So we have 45-degree angles is root 2 over 2, and everything else in between. So now let's go ahead and graph our sine function. And if we kind of think about like, hey, positive, negative, general idea about this. So if we're thinking about our values here, we're going to be positive, positive, negative, negative, okay? So kind of keep that in mind as we move through our sine function here. So this, of course, we're starting with 0. 0 is going to be 0. Pi over 4 is going to be root 2 over 2. I'm thinking of our answer. We're going to go all the way up to 1. We're going to come back down through root 2 over 2. We're going to go through 0. And then we start moving through some of our negative ideas here. So we have negative root 2 over 2, negative 1, negative root 2 over 2, and back to 0. And again, we kind of keep up that pattern here of positive, positive, negative, negative. So we have positive, positive, negative, negative. All right, let's plot these on our graph here. And before I plot our graph, I want you to take a notice of how our x-axis is now labeled. We have it in terms of pi, and then our y-axis here is going to be labeled however we need to. For this one, it's labeled by 1 and negative 1. All right, so we had 0, 0. We have root 2 over 2, which is about like 0.7, so kind of up here. And then pi over 2 is 1, and then back kind of down through here, 0, and then we kind of go in these negative directions. So somewhere kind of around here and back through there. And as you can see, and you probably have known this from like you've probably heard of like a sinusoidal curve, is that it kind of creates this curve all the way through here. So we can go ahead and start by just kind of connecting and curving. Be as careful as you can. My Apple Pencil's getting a little shaky here. There we go. So this is one cycle. It's 1 over 1 period that we have here over 2 pi. And then, of course, it is a periodic function, so this pattern just ends up kind of repeating itself. So we can also go in the negative direction, so we can go down through here. If you'll notice, I will start to just kind of plot our points. Like I didn't plot our root 2's over 2 because I know that I'm going to come back through here. I'm going to connect it with a curve and then come back through this way. Oops, let's try that one again. It's going to look like that. So, of course, this is our parent function, so take a peek at it, get to know it. Everything from here is going to be kind of adjustments. As we can see, our domain is from negative infinity to infinity. Our range is from negative 1 to 1. Some good things about it. The other thing I kind of want to point out is, of course, I said this before, which is you want to scale, of course, your x-axis. And the other one you want to scale and make sure you have up here is scale your y-axis. All right, so there's our first trig function. It's our sine function, and you can kind of take it right. Starts at 0. Some good things to note here, of course, starts at 0, goes up, ends over here at 2 pi by coming back down. So getting used to kind of this curve idea. Let's also look at our cosine, and when we're thinking about our signs of cosine here, we're going to go positive, negative, negative, back to positive. right? So keep that in mind as we are graphing this. So some purple. All right, same thing here. We're going to go ahead and plug in some zeros. Sorry, my 0 got kind of pushed over there, so the 0 should be in that one. So 0, 1, this is going to be pi over 4, so root 2 over 2 down to 0. Now we're in quadrant 2, so now we're going to be negative. Negative. I'm still sticking in quadrant 3, so negative. And up to 0, now positive in quadrant 4. And back out to 1. So kind of keeping that like, okay, positive, negative through here, and then back to positive. So now let's look at what this looks like on our graph. So we're now starting at 1, kind of coming through that root 2 over 2, down to 0. Again, kind of coming through that root 2 over 2, negative, back to 0, root 2 over 2, and back up to 1. So this curve now kind of starts at 1, comes down, and goes back up. It actually follows the same pattern as your sine. If you kind of look at this one, just kind of portion of it in this way. If you kind of think about it, I'll erase these, but right, this is our sine parent function right here, this little section where you start at 0 and kind of move up. Now if you think about your cosine is the one that starts at 1, so kind of like this section right here starts at 1 and comes back up. So you can kind of think about it that way. And you have this curve that comes down, comes down, comes through, and back up. And then of course it goes in the other direction. And again, you'll start to see how I just plot the kind of zeros and the max and mins here, because you can use your curve to show the other points there. What's your cosine? And again, this is your parent function. So get to know it. Big key is that, of course, cosine starts at 1 on your y, and sine starts at 0 on your y. Again, our domain and range are the same here, negative infinity to infinity. Our range is from -1 to 1, and you'll notice again how the y and x-axis are scaled there. Okay, so now let's go ahead and talk about our transformations with these. So we're going to go ahead and go with sine of x plus 1, which means that we are going up 1. Basically what this does is it moves the midline. As a reminder, that midline is the line that goes right through your function. So what this is going to do is going to take that midline and shift it up, right? So this shifts midline. And the key thing with these is you want to make sure that everything is scaled. That's the whole key. So we're going to scale this by, I need to look for 2 pi on this one. So I'm going to break this up into pi's over 2. So this is going to be pi, this is going to be 2 pi, this is going to be 3 pi. And if you want to actually label every single x-axis, or line on your x-axis, you can. But from here we can tell that, okay, if this is pi, then this is going to be pi over 2. Right? And so on and so on. And then I like to go in the negative direction as well. So negative pi, negative 2 pi, negative 3 pi. All right. And now we're going to go ahead. We're also going to scale our x-axis. So my y-axis. My y-axis is just going to go by 1s. So I want to make sure I note that there. All right. So now it's time for us to graph. We know that we're being shifted. All we're doing on this one is that we're shifting it up 1. So we're going to go ahead. We're going to start here. I'm going to start here because it's sine, so we're basically starting right. We're starting at that 0. And I'm going to end up going up and coming back down. So how we want to practice graphing this is I'm going to find, I know my period length is going to be 2 pi, so it's going to take this entire time right here to go from starting point to ending point, 1 cycle. The middle point for sine is where it comes back and crosses. And then I know that I go ahead and I go up and back down. And that gives me 1 period that I have there. And then you can go ahead, you can keep that pattern going. You can go up and then back down on this one, and in the negative direction as well. through 0 up to 1, through 0 down. I'm saying 0, but that's because my midline is shifted here. And then you simply just get to take your pencil and make the best curve that you can through your points. Again, mine is a little shaky with this Apple Pencil. It doesn't quite give me the control that we want on that one. But there is your first transform sine function. Simply just going ahead and kind of shifting up that midline right there. All right, so on our horizontal shift, we call this a phase shift. So this is a phase shift, and I put a little note down here is that as a reminder, of course, your phase shift can only be seen when you can factor out, right, when you have that coefficient of 1, so make sure to factor it out when need be. We do have a coefficient of 1 on our x, so we're okay here. So once again, I'm going to think about scaling my graph here, and I'm going to scale this. Actually, we're shifting by pi over 4, so I'm going to scale this a little bit differently because I need units of pi over 4. So this is going to be pi over 4, which makes this pi over 2, which makes this pi. And then also in the negative direction, think of this negative pi over 2, and then negative pi. Not my best on scaling these. Sometimes I like to make sure we have it kind of even. So I'm going to put this as pi over 2 so that we're even on both sides. Now for this one, I'm going to put my 1 and my negative 1. I'm going to have 2 units. I'm going to go by 0.5 on every box, just so that we kind of spread it out and give ourselves room to work. Okay, so the reason that I did that on this one is because I'm shifting by pi over 4. So we know on this one that we're going right to the little pi over 4 amount. So I'm going to go ahead, I'm thinking about cosine. Cosine I'm going to start at, so my parent function would be here. So I'm just simply going to shift this over this amount. And we know that we end up going through a full cycle of 2 pi in order to get there. So the other way that you can kind of think about this when you don't have enough room on your graph is you want to think about like if you can find a section of 2 pi that you can work with. So we're going to come back down through here, and then this goes through 3 pi over 2, and we're kind of just shifted over just a little bit. We're going to come back up through here. And as always, if need be, don't forget you always have the option of plugging in points, right? You can always go ahead and start plugging in some values and see if you are correct with your points. Again, my curves aren't quite working very well, but that's kind of the main idea there, right? And if you kind of think about, hey, we got that cosine, right? That cosine is just kind of, it's shifted over just a little bit there. All right, so now that we've talked a little bit about those shifts, let's remind ourselves, in general, we have these 2 general functions, right? Where we have a of cosine times bx minus c plus d. You're all very familiar with what these stand for in terms of our horizontal vertical shifts, which we're now calling a little bit like things a little bit different. For instance, A stands for now amplitude, and amplitude is half the distance from the min to the max. In the parent function, we said, hey, the amplitude is 1. If you want to go ahead and kind of look at that again really quickly, we know that the distance from the midline all the way up is 1. Okay, so now that we go ahead and we add on some, oops, get a pencil here, right? Let's think of that parent function of y is equal to cosine of x. So we start at 1, come down through pi over 2, down through this one, 3 pi over 2, and 2 pi, right? So this is our cosine. Let's go ahead and kind of connect it with the best curves that we can. Not really happy with that one. Just kind of come through this one. There we go. All right, so that's our cosine, and then let's talk about what happens when we change the amplitude. So if I'm now going to change the amplitude to 1/2, meaning that from our midline, so our midline's right here at y equals 0, we're only going to be going up 1/2. It's very similar to our dilations, and we're going to go down 1/2 from here. So we're now only going up a half, down a half. We're still going through 0, up a half on this one. So again, it's very similar to what we've called either stretches or dilations in the past. And one more with the 2, you can probably guess what it's going to do. You're now having an amplitude of 2, so you're going all the way up to 2, all the way up to 2, all the way down to 2, and then of course you still go through 0. So again, taking your pencil as best you can. All right, so this is now our amplitude, right? So as it says here, therefore our amplitude is equal to this absolute value of A for sine and cosine curves, okay? So FYI, that's what that A stands for, that you're looking for, that amplitude. All right, now let's talk about the period. And of course, we know that the period is the horizontal distance it takes to go one cycle. Distance it takes to go one cycle, right? So in the parent function, we talked about, hey, the period of it is going to be 2 pi, right? 2 pi is 1 revolution all the way around the circle. All right, so therefore, if sine of x has a period of 2 pi, it follows that this would go ahead and now have from x is equal to 2 pi over b. So this conversion right here, therefore the period of 2 pi over b for sine and cosine curves. And it's actually almost a little bit easier, I think, than some of our dilations that we've done in the past, is that you simply just have to take that b value and, of course, make sure that you, of course, factor it out when need be, is that you want to take the b value over 2 pi. So if we're thinking about this first one, right, just parent function, so we have sine of x, we have an amplitude of 1, our period is going to be 2 pi. Again, our amplitude is going to be 1 here, but now we're going to go, hey, what's our period? So we're going to take 2 pi over 1/2, which is equal to 4 pi. So meaning that it's going to take 4 pi to go through one cycle. We'll see what that looks like in just a little second. This one is going to be 1, and we're going to take, our period is going to be 2 pi over 2, aka just pi. Okay, so let's graph some of these, and as always, we of course need to scale our graph over here. I'm going to have to get through 4 pi, so I'm actually, let's see what I can do here. We're going to have, let's see if I, pi, 2 pi, let's see if I get all the way to 4 pi, 3 pi, I did, I made it 4 pi, okay, so that's because one of them I'm going to have to get through 4 pi, the other ones we're going to have a little bit different. And if we give ourselves a little bit of room, let's do 1 and -1. Let's start here with our parent function. So we have our y equals sine of x, kind of getting used to graphing these. And again, I'm going to go to 2 pi. I'm going to go halfway through at 0, and then I'm going to make my maximum and my minimum here. And then you're going to repeat that pattern, right? So you're going to go up and through, down and back through. And take your pencil. There we go. Getting a little bit better with our configuration here. And actually what I really should do and get in the habit of is completing it all the way through the graph here, no matter what is labeled or not. That's not correct. There we go. Okay, so there's our parent function. Now let's look like what happens when we have x over 2. So I will take this in purple here, and we know that we now have a period of 4. So watch a little bit how I graph this. I will zoom in just a little bit here for you. So again, starting at 0, and then I'm going to go to my ending amount, which is going to be 4 pi. And then I'm going to find the middle of it, because I know that I'm going to come back through it. So the middle of that is 2 pi. Now the middle of these two sections is going to be where my maximum is and my minimum is. So now I can find the max here at pi and the minimum here at 3 pi. And now I can go ahead and take my pencil and do a curve through my points. All right, so same thing for when you have a period of pi, and you'll start to see the cycle starts to get a little bit more repetitive because it's a shorter period. Let's graph this in, we already used purple, we'll do this kind of dark purple here. So we're doing y equals sine of 2x, and we now have a period of pi. So on this one, again, we kind of say, hey, we're going to start here. Actually, I'll do a different, no, it's fine. And end at pi, halfway through pi over 2, top and bottom. So I know that I'm going to go ahead, I'm going to have this cycle right there, that one period. And you can go ahead, you keep that process and keep it repeating. Come back down through 2 pi, up through 0, down through 0, up through 0, down through 0, up and through 0. So you can go ahead, take your pencil, and those colors kind of starting to run together, but hopefully you can see the difference between them, right? And what those different periods look like. All right, so you can take a peek at these pro tips, right? We're gonna go ahead, we're gonna use the period to mark off the scale of the graph, then use our phase shift to find our new starting point, mark the end of one period, halfway point, and then so on and so on, right? And then double check that our amplitude and reflections have all been accounted for. So let's go ahead and do it. We have our first example, which is y equals 1/2 cosine 3x. I'm going to start by writing our good information that we need to know here. I'd like to start with our amplitude. We know that our amplitude is going to be 1/2. Okay, so I'm not going to be going up that much. We're going to find our period here. Our period is going to be 2 pi over 3. There's nothing else I can kind of do on that one. That's kind of a fun one. We'll look at that in a little bit. And then we also know that we have a vertical shift of up 1. So we know from here that that midline is going to be at y equals 1. Just some good information here. All right, so from here, it's time to scale our graph. So I know that when we're scaling our graph, I know that I'm going to have to get through 2 pi over 3. I also want to be able to split up 2 pi over 3 into 2 sections. So I know that I'm going to want pi over 3, so I'm going to start here with pi over 3, and then I'm going to have 2 pi over 3, and this is going to get me to 3 pi over 3, aka just pi. All right, and then I'm going to go in the other direction, of course, as well. So this is negative pi over 3, negative 2 pi over 3, negative pi. Okay, and then for our y's, I'm going to have to go by 1/2 because my amplitude is 1/2, so I know I'm going to be 1 and negative 1. Okay, now that my graph is scaled, now I'm ready to plot. So it's a cosine graph, meaning I'm going to start at 1, but I'm shifted up 1. So I'm going to start from, right, so here's my new midline, and I would be starting up at the 1, but it's an amplitude of 1/2, so I'm only going up 1/2. So starting up 1/2, and I know I'm going to go ahead, I'm going to finish at, the period, that one cycle at 2 pi over 3. So I'm then going to find the middle of it and go down, and then I know that I'm going to be passing through 0, or our midline on this one, halfway through. So this is, if we look at it, this is going to be one cycle of it, right? One cycle that we have right in here. If you want to, you can kind of sketch that out so you know what you're looking for, kind of looking at that. And then you just get to kind of start repeating that pattern over and over. Oops. Coming back through all the way up. And then take your pencil as best you can and start your curve. Right? And just double checking, hey, is our midline at 1? That it is. Our amplitude is 1/2. Yes, it is. All right, and it's taking 2 pi over 3 to go through one cycle. So all the things you can go ahead and check about your functions here. All right, last one here is y equals negative 3 sine of 2 pi x over 4 pi. So this one kind of gets a little bit interesting. So kind of pay attention to some of the things that we talk about here. Number one, of course, I'm going to factor out this, our value of 2 pi. So we have negative 3 sine of 2 pi times x plus 2. This allows me to see my phase shift here. Okay, so now let's talk about all the things that we have here. We know that our amplitude, right down here, our amplitude is going to be 3, but we also know that we have a reflected over the x-axis because we have that negative out there. So let's keep that in mind as we're graphing this. Our period, let's talk about this. This is the most important part of it. It's going to be 2 pi over 2 pi, aka 1. This is something a little bit different than what we've seen in the past. It's only going to take 1 unit, literally 1. We're not talking about pi's now, not 1 pi, but 1. And then we also have a phase shift of left 2. All right, so now it's time to scale this graph, and this scale is going to look a little bit different because my period is 1, and again, it's not 1 pi, it's 1. So I need to get through 1 unit. I'm actually going to go ahead. This is going to be a half. This is going to be 1, 1.5. This is going to be 2. And also in the negative direction, negative 1, negative 1/2, negative 2 over here. Because I need to go of an amplitude of 3, I need a lot of room to work here. So I'm just going to scale this as 1 and 1 there. So we can use that. Okay, so my period is only going to be 1. And again, I'm not talking about pi's anymore. I'm talking about 1 unit here. So we are going to, and we're going to be doing a sine function here. Now, what's kind of cool about this sine function is that it is shifted over 2. So what I actually should be doing is I should be starting here. But if you notice I start here, I have nowhere to room. I have nowhere to go. So I kind of want to think about like, hey, what happens on this shift is that you are kind of shifting your whole thing. So we would be like starting here and we'd be going up. So what's cool is that I can actually start here and kind of forget about my phase shift a little bit because I would be starting here and going up and it would take me 1 cycle. So I actually get to start here at 0. Now and it takes me 1 whole unit to reflect. Halfway through, it's a sine function. I'm going to come back through. Be careful though, because remember, we're reflected over the x-axis. So I'm not going to be going up. I'm going to be going down. So down 3 first, and then you go up 3, because it's a reflected one. And if you want to, again, like kind of sketch your first cycle here on that one. And then keep up your pattern there. So we're going down 3, through, up 3, through, and then on the negative side, up, through, down, through, up, through, down, and back through. Then take your pencil and go through all of these points that you just made. And again, that phase shift was a little bit funky, but as you can see there is that sometimes you have to kind of adjust your graph a little bit with what you're given, and it is shifted over. The cool thing also to kind of point out about this is that these graphs can be represented in many different ways. For instance, if this graph is the same as not having this phase shift right here, right? So just a little heads up on those. Take a peek for, sometimes you can have them in many different